Mars, the red planet. For millennia, this celestial neighbour has captivated humankind. Its fiery hue, easily visible in the night sky, sparked tales of gods and war. As our understanding of the cosmos grew, so too did our fascination with Mars. Was it a dead world? Could it harbour life? The questions lingered, unanswered, fueling our desire to reach out and touch this enigmatic world. The allure of Mars lies in its potential. Of all the planets in our solar system, Mars is the most Earth-like. While Venus may be closer in size, its extreme temperatures and toxic atmosphere render it inhospitable. Mars, however, holds the promise of a world we might one day explore and even inhabit. This possibility has fueled countless science fiction novels, films and scientific studies. It has sparked international collaborations and driven technological innovation. The journey to Mars is not just about reaching another planet. It's about pushing the boundaries of human ingenuity and unraveling the secrets of our solar system. Mars is the fourth planet from the Sun. It's significantly smaller than Earth, with a diameter of roughly 4,200 miles. Its gravity is weaker than Earth's, about 38%. A day on Mars, known as a sol, is slightly longer than an Earth day. A Martian year lasts 687 Earth days. The Martian atmosphere is thin, composed primarily of carbon dioxide. This thin atmosphere offers little protection from the Sun's radiation. Temperatures on Mars can plummet to -200 degrees Fahrenheit at the poles. The surface of Mars is a testament to a dynamic past. Vast plains of volcanic rock dominate the landscape. Evidence suggests that liquid water once flowed on the surface. Today, this water is largely locked away as ice beneath the surface. Despite our growing knowledge, Mars still holds many mysteries. One of the most intriguing is the question of life. While no definitive evidence of past or present life has been found, the presence of organic molecules and evidence of past liquid water suggests that Mars may have once been habitable. Another mystery lies in the planet's two moons, Phobos and Deimos. These small, irregularly shaped moons are thought to be captured asteroids. Their origin and composition remain subjects of ongoing research. The exploration of Mars is not just about satisfying our curiosity, it's about unraveling the history of our solar system. By studying Mars, we can gain insights into the formation and evolution of rocky planets, including our own. The allure of Mars has captivated astronomers for centuries. Galileo Galilei, in the early 1600s, was the first to observe the planet through a telescope. His observations, while rudimentary, marked the beginning of our scientific study of Mars. In the following decades, astronomers like Christian Huygens made more detailed observations. Huygens was the first to observe surface features on Mars, including a dark region later named Syrtis Major Planum. These early observations, while limited by the technology of the time, laid the groundwork for future exploration. As telescopes improved, astronomers were able to map the Martian surface and observe seasonal changes. They observed the growth and retreat of the polar ice caps, leading to speculation about the Martian climate and the possibility of water. These early observations, fueled by curiosity and a desire to understand our place in the cosmos, sparked a dream of one day reaching this distant world. The dream of reaching Mars would, in the coming centuries, transition from the realm of science fiction to a tangible goal. Section 5. Pioneers of Martian Exploration, the Dawn of Discovery. The mid-20th century marked the beginning of the space age, and with it, a new era in Martian exploration. The Soviet Union launched the first missions to Mars in the early 1960s, though most of these early attempts ended in failure. In 1964, NASA's Mariner 4 spacecraft became the first to successfully fly by Mars, sending back the first close-up images of the Martian surface. These images, though grainy and limited in scope, revealed a cratered and barren landscape, challenging earlier assumptions of a more Earth-like world. Undeterred, NASA continued its exploration with the Mariner program, sending a series of spacecraft to orbit and study Mars. These missions provided valuable data on the Martian atmosphere, surface temperature and geology, paving the way for future lander and rover missions. The race to Mars had begun, driven by scientific curiosity, national pride, and the desire to unravel the secrets of our celestial neighbour. Section 6. Viking to Pathfinder, Unraveling the Martian Surface. The 1970s saw a significant leap forward in Martian exploration with NASA's Viking program. Two identical spacecraft, Viking 1 and Viking 2, were launched in 1975. The Viking landers touched down on the Martian surface in 1976. They sent back panoramic images, conducted experiments, and analyzed the Martian soil. While they didn't find definitive evidence of life, they provided a wealth of data. The Viking missions confirmed Mars's dry, dusty conditions and ancient volcanism. In 1997, NASA's Pathfinder mission landed on Mars. Sojourner, a small rover, captivated the world as it explored the Martian landscape. Section 7. Rovers on Mars, Spirit, Opportunity, and the Search for Water. The early 21st century witnessed a new generation of Martian rovers. In 2004, NASA landed twin rovers, Spirit and Opportunity, on opposite sides of the planet. These rovers, far more capable than their predecessor Sojourner, were designed to explore the Martian surface and search for signs of past water. Spirit and Opportunity vastly exceeded their planned 90-day missions. Spirit explored for over 6 years, while Opportunity continued its mission for an astonishing 15 years. Their discoveries revolutionized our understanding of Martian history. Both rovers found evidence of past liquid water on Mars. Opportunity, in particular, discovered minerals that form in the presence of water, providing strong evidence that Mars was once a warmer, wetter world. Their findings fueled speculation about the possibility of past life on Mars and inspired future missions to search for signs of ancient life. Section 8. Curiosity and Perseverance, Advanced Explorers on Mars. Building on the success of Spirit and Opportunity, NASA sent even more advanced rovers to Mars. In 2012, Curiosity landed in Gale Crater to reveal clues about Mars's past habitability. Curiosity, larger and more sophisticated, analyzes the Martian environment in detail. It drills into rocks, analyzes their composition, and detects organic molecules. In 2021, Perseverance landed in Jezero Crater, searching for signs of ancient life. Perseverance collects rock and soil samples for eventual return to Earth. Its mission could answer whether life ever existed on another planet. Section 9. India's Triumph. Mangalyaan reaches Mars. While NASA has been at the forefront of Martian exploration, other space agencies have also made significant contributions. In 2014, India's space agency, ISRO, made history by becoming the fourth space agency to reach Mars with its Mars Orbiter mission, also known as Mangalyaan. Mangalyaan was a technological marvel, developed and launched on a shoestring budget. Its primary objective was to study the Martian atmosphere and search for methane, a potential sign of life. The mission was a resounding success, providing valuable data on the Martian atmosphere and capturing stunning images of the planet. Mangalyaan's success demonstrated India's growing prowess in space exploration and inspired future missions. Section 10. Global Collaboration, Expanding Our Horizons. Mars exploration has become an increasingly international endeavour. The European Space Agency has played a significant role, launching missions like Mars Express and ExoMars. Mars Express, launched in 2003, has been orbiting Mars for over 2 decades, providing valuable data on the planet's atmosphere, surface and subsurface. ExoMars, a joint ESA-Roscosmos mission, aims to search for signs of past or present life on Mars. The mission consists of 2 parts: the Trace Gas Orbiter, which is currently studying the Martian atmosphere, and the Rosalind Franklin rover, which is scheduled to land on Mars in the late 2020s. Other space agencies, including those of China, the United Arab Emirates and Japan, have also launched missions to Mars, or plan to do so in the coming years. This global collaboration is essential for advancing our understanding of Mars and paving the way for future human exploration. Section 11. Mars, a Future Outpost. The exploration of Mars is not just about scientific discovery, it's about pushing the boundaries of human exploration and pushing the limits of our technological capabilities. The ultimate goal for many is to send humans to Mars. Such a mission, while challenging and expensive, would represent a giant leap for humanity. It would require international collaboration, technological innovation, and an unwavering commitment to exploration. Imagine a future where humans live and work on Mars, conducting research, exploring the planet's surface, and perhaps even establishing permanent settlements. While such a vision may seem like science fiction today, the steps we are taking now, with each successful mission and each new discovery, are bringing us closer to making this dream a reality.